Alrighty. Hey there, folks. First time using this software. Hi, my name is Andrea Parker. I'm an MLE over at Weights and Biases. My background is in information retrieval and natural language processing. So I've been doing this for about a decade, working with language models and text data and all that fun stuff in a wide range of domains. Sometimes medicine, sometimes financial related data, and yeah, so today we're going to be kind of covering how you, as a developer of one or on a team of folks, can engage in reproducible research and reproducible building of large language models, like our friends and colleagues at some of the great research orgs that are building these large scale transformer models. And before I get into today's discussion, today's lecture, I just wanted to make sure to announce these two courses. This kind of probably really well builds off of what just went on the previous speaker's call. And also, if you want to look online, there is a webinar that I co-hosted with Pinecone, with James from Pinecone, back in October or November of last year. So all sorts of vector space model fun, working with weights and biases and sentence transformers to build a cool little toy task. So that's awesome to get your feet wet with weights and biases, plus with NLP if you haven't played around with that before. And so on today's agenda, it's a half an hour call, so we're not going to go super deep on some of this new stuff, but I will provide some links and you'll get a copy of the slide deck at the end so that you can explore at your leisure what we discussed today. And so today we're going to cover kind of an intro to how we got to where we're at today in natural language processing in generative pre-trained transformers. And then we're going to cover reproducibility, like how you can use the same tools that folks at these large research orgs are using to build really awesome, really performant, and quickly iterable large language models. Then, if you have used weights and biases tooling before, you may have known that we do experiment tracking and all kinds of other cool end-to-end lifecycle things in the model building and testing and deployment lifecycle. But we have a new functionality that we just released last week called WMB prompts. And as its name implies, it's related to prompt engineering and prompting and large language models. And along with that tool is another new recent release called Launch, which allows you to kick off and provision jobs remotely from your machine. So you can say, I want to kick off a OpenAI evaluate job. You can do that with the Launch functionality. And then finally, at the end, we're going to have some time for Q&A. So you look at all these orgs that use weights and biases, and what do they have in common? To my eyes, what they have in common is because they use our tooling and a whole bunch of other great tools out there, which I'm sure you'll see today, like Mosaic ML, all these awesome assistive ecosystem tooling for your NLP experimentation and your model tracking and development. While we all use this, like weights and biases is a core kind of Lego brick in your modular ML engineering, DL engineering, LLM engineering ecosystem. And as someone who's been using this tool for about a year now, I can say that there are kind of three main pillars of what I see weights and biases really excelling at. It allows me to rapidly iterate on my models to, rather than spend time kind of digging through the weeds and trying to remember how I kicked off a job, what my hyperparameters were, we can log all of that ourselves. And so then I also can remember like what flavor of machine I had provisioned a job on. So all of that like is cataloged automatically for you. It's like if you had a buddy in your chemistry class sitting next to you taking all the lab notes. That's kind of how I explain weights and biases to my friends or colleagues who might not be in the ML space. Additionally, the second main pillar is reproducibility. By acting as like a lab mate, lab buddy assistant, the product allows you to maintain continuity as you're building these models. Like, let's say your teammate switches over into a different universe at your workplace, or bunch of friends and colleagues get pulled off to work on something else, you can still kind of just pick up where they left off. And along with that reproducibility angle is the collaborative angle. So this allows you, Weights and Biases allows you, either with your kind of heads-up display or with a functionality called reports, to transfer your knowledge to technical and non-technical colleagues. If you've ever worked in a workplace where maybe some people don't use Jupyter notebooks, you're, let's say you're product folks or something, and you're trying to communicate intermediary findings to them, that's often a challenge. And so what I really dig about Weights and Biases, and something that has helped me as an NLP person communicate intermediary and final findings to my colleagues, is the ability to fire up a notebook, which you can kind of think of as a blog post. Those folks on non-technical teams can leave comments, inline comments at the beginning or on any text or at the end of an article. And so that really helps close the feedback loop for all stakeholders on these models that I'm building, whether they are in product or whether they are up in the C-suite. It's just really great to know that, hey, you're on the right track with this, or we're looking for something else. And recently, while working on a summarization model for podcasts, if you listen to Weights and Biases podcasts called Gradient Descent, I was kind of helping build this model that would take an hour plus long audio recording and generate a brief 1-paragraph summary. That paragraph summary could then in turn be uploaded to like Apple Podcasts or what have you. And that just seemed like a more straightforward workflow than kind of kicking the summary task over to maybe a colleague who's not a machine learning engineer and asking them to write a summary on this dialogue between our CEO, who has a background in NLP, and some other technical person who are like talking with their nerd lingo. And so that summarization model, my intent behind that was really, let's create a model that, so that the content team doesn't have to sit there and rack their brain about what all these domain specific words mean in natural language processing or in computer vision or what have you. And so by creating that model and then stashing it up somewhere publicly, we'll cover this briefly later on, there are some researchers who are picking up and kind of mining these public projects, and they're back testing them against main classes of like pretty performant NLP models. So you have BERT, you have Roberta, Flan was another one. And so in my case, a research team at IBM actually picked up the model, back tested it, and for a lot of the different classes that they tested the model against, it actually outperformed the original model, so the unfine-tuned model, by like 20-25%. And so I'll cover this later, but there's some really rad potential there for being able to take these models that you have fine-tuned or I have fine-tuned and fuse them together to create like a super performant model. So that along with what OpenAI is doing with their eval library, which I'll briefly cover as well, is just a super rad, collaborative, reproducible, rapid way to build performant, large-scale models that work across a wide range of domains. And so it's a super exciting time, especially if you've been doing NLP for some years and there kind of wasn't much movement for a while.
Andrea, sorry to interrupt, but could you put this in slideshow mode?
Sure.
So the viewers can see it a little bigger. Awesome. Thank you.
Sorry about that. Yeah, so to that end, teaching machines to understand language, while not all of our tasks are solved, I think a lot of us can confidently say that NLP, NLU, NLG isn't still hard. It was hard, especially with all of the recent developments in the past like month or so, OpenAI, Cohere, Anthropic, all of those amazing generative pre-trained transformers, even the multimodal ones that have come out, those are just amazing. And they can understand a wide range of human language, even domain-specific stuff that historically would have really tripped up your old school NLP models. And so just for folks who have kind of less exposure to natural language processing, I'll give you a brief 2-minute rundown of kind of where we were before and where we are today. And so back in the 50s, 1950s and 60s, we had these things called bag of words, which were where you take all the words in a document and you, like the name implies, you put them in a satchel. And that model, then your whole pile of words in a bag, makes up what your document is about. Obviously, if you're just throwing words in a bag, this doesn't capture context quite well. Your word orders can get flip-flopped, like fuzzy cat gets flip-flopped for cat fuzzy, or other strange stuff like the bird ate the cat ate the bird. Both of those would be captured in the same way in these old school models. And then in the 70s, there were some advancements. This thing called term frequency, inverse document frequency came out. Still, or until some years ago, was moderately important in search and in information retrieval. And then kind of really not much happened for a few decades there, to be honest. Compute was a limitation. We didn't have GPUs sitting around at everyone's house with their laptop or in their workplace. Data was also a limitation, data by way of GPU. So getting all of that data efficiently onto a processing unit and then performing your matrix multiplication on it. So the data and the compute just wasn't there to kind of make really rad advancements outside of academia. So here in the second little shape, you can see RNNs and LSTMs. In the 1990s, you started having cool things like bidirectional recurrent neural networks to capture your left to right and your right to left dependencies. Then kind of some years later, in the early 2010s, we started getting these cool things called embeddings. And two main flavors of embeddings that you may have heard of. You could look at Word2Vec, you could look at Glove, and those start to capture the meaning in high dimensional vector space. And so this worked like pretty well for a while, definitely better than like trying to do something with an LSTM. But then a few years later, in 2015, we got these papers starting on attention mechanisms. And those were pretty cool. But the real breakthrough kind of came in my opinion, in 2017, when transformers were introduced. And that allowed you to kind of wipe the board clean of your LSTMs, of your recurrent neural nets, and the performance on these initial transformers, language-based, were amazing. We quickly figured out that you could then apply those transformers to like vision-based tasks or all kinds of other tasks like protein folding, wildly like distant tasks from language like protein folding. Who would have thought? Amazing. And then since 2017, so starting about 2018, when BERT was released, that was when these large-scale pre-trained models started to really take off. And so you got BERT, Roberta, all of that. And then some years later, obviously, GPT, GPT Neo X from Eleuther. And so this over here on the left, you can see kind of cool, some attention going on. And just to kind of clarify how massive transformers were and how much evolution they contributed to in the NLP field. On the right there, you can see all the really cool tasks that you can use transformers for, in addition to the words prediction. So that's, and I'll share these slides afterwards, so you can click on that hyperlink. That's a great paper from folks at Google. But building from scratch or even fine-tuning your models was really challenging. And even today, let's say you're working on some domain-specific tasks, or you have other challenges in your data. Maybe you don't have a whole lot of data. Maybe your data is pretty messy. You gotta just kind of general data quality issues. That could still present some challenges for transformer-based models. And so kind of to illuminate what I think is an alternative to some of these trickier training processes, would be how weights and biases can take this, which is your model training's output on the command line, and then maybe you've pasted it into a spreadsheet, or you've gotten really fancy and you've put it in TensorBoard. And that works well for a time, but what happens when you're running like tens or dozens of iterations of these experiments? Let's say you're trying different training data sets to fine tune, or different fine tuning data sets for your model. When you're fine tuning it, you're taking an off the shelf transformer that someone else has already trained. And quickly, like you trying to keep track of these results manually, or even with the assistance of a computer and your spreadsheets, it becomes really unwieldy. And so for that, we have weights and biases. And these initial 6 products here on the left are things that already existed. If you've used weights and biases, you're probably already familiar with them. But the 2 on the right, launch and prompts, are brand new product functionalities. And so with prompts, as you can guess by its name, it is LLMops. So anything to do with large language models. And these initial kind of 6 boxes here, those handle your training from scratch. So let's say none of the models out there, none of the large language model APIs as a service are of use to your business. Maybe you have security concerns. Maybe the domain isn't great and it's not performing well on your data. In that case, maybe you want to train a transformer model from scratch. Weights and Biases has tons of already existing tooling to support you with your model training from scratch. And as you could see earlier, when we had those logos of different customers, Mosaic, OpenAI, all those folks, they are the ones kind of training these models from scratch using our tooling. And so to support not only engineers who are training from scratch, but folks who are fine-tuning LLMs to their company's specific lingo or specific tasks, we want to be able to support that as well. And then finally, folks who are prompt engineers. That is quite a new title in the workplace, but people who are using kind of LLMs as a service. And so those folks are engaging with the APIs, but they're not doing any fine-tuning of generative pre-trained transformer models. And they're not really doing any, I don't know, maybe taking your data set and generating some new embeddings on it, like those LLM fine-tuner folks might be doing. And so we really wanted to make a flexible, adaptable use case product that allowed us to hit all of these 3 main personas. And so to that end, we have these new functionalities here, which I could share with you. There's a great prompts documentation page. And so this will teach you basically how to do anything you want to via those 3 personas. We have a notebook, and this URL will be shared as well. I know it's a little hard to see, so yeah, you can kind of work on this at your leisure. There's no coding that you need to do. You can paste in an API key and hit the ground running. And also, too, this page might be a great overview if you want to understand kind of some of the main functionalities of the tooling. But so getting back to prompt, what it does is you can see kind of we have these tracers over here. These are some queries that we've input. We've asked it to do some math, which you'll see in the notebook if you play around with that. And then you can also view kind of processes. What went wrong? Did my job successfully complete? Some time deltas. How long did this take? Lately, GPT-4 has been kind of, smoke has been coming out of it in the evenings and on the Pacific time. And I noticed that the performance is a bit degraded. So being able to see when I have long running jobs is super helpful. Additionally, you can see your output of your queries that you fed the model, the execution chains over here. And also this is when you run the notebook and you scroll down, you'll see this. This is kind of a visual representation, like a tree of the order of operations, the calls that are happening when you execute a query. It tells you which model you're using, what temperature you used. If you're familiar with using weights and biases for your model training, this probably looks pretty similar, where you have, oh, I had, let's say, a learning rate of whatever your learning rate was, or you had a batch size of 32, these kind of hyperparameters about your experiment. Those are provided in your normal weights and biases UI, and then here, again, as well, for your LLM stuff. And so, yeah, this this allows you to do all kinds of flexible things. And like the previous speaker mentioned, because of the different large language model APIs that are exposed via the LangChain tooling, you can slap your Cohere API call in here. You can put your OpenAI one. There are so many different libraries that you can choose from, or different APIs that you can choose from, excuse me. And so you can just pipe that through the LangChain kind of wrapper. And so another really rad thing that I like is this functionality. So previously I was talking about prompts, and there is this really cool new functionality. Again, last week we launched it. It is called Launch. And so what Launch lets you do is, as the name implies, kick off some sort of job. And with this, you can click on simply a launch button. It will start a job. That job will run remotely somewhere. You can get some statistics really, really high level up here as to which version of the model job you kicked off, the hour when you ran it, as well as details about your job. So these are kind of like a model card-ish sort of thing. And this also provides you with what was happening when I ran the run. Okay, there's its name. What is its state? Did it successfully finish? We're working on the project Emotional Intelligence, and here we can see the prompt that we fed into the model, and we're using GPT 3.5. Again, so this is the evaluation way, using the OpenAI evals library to kick off a launch job. So a launch job doesn't have to be OpenAI's evals. It can be whatever the heck you want to do, some sort of, I don't know, a model retraining workflow. And so it's really cool being able to stick like arbitrary kickoff things, jobs to start inside of the eval tooling. So yeah, here you can see, again, the OpenAI evals thing. But what I really like is you can take the outcome of these evaluation jobs. And this is for a manga translation project that a coworker made. And so this kicks off the evaluation process, and then you can generate a report. This is what a report looks like, with kind of some summary statistics about what's going on and what flavors of custom prompts you fed into the model. You can chart here and say that our red prompt is doing a bit worse, actually, than our original V2 flavor prompts. You can kind of see the delta there between the red and the blue. And then you can also take a gander at your input and your output. What's going on with your model? Did the answer, was it correct? And yeah, all kinds of other metadata. And again, like your standard weights and biases runs and all kinds of stuff like that, you can see them here, as well as lineage, the jobs that went into building your training data, as well as things that are consuming your data. So if you have kind of a long system where you have a pre-training job or a pre-processing job, that text data goes into your model generates some output data, which is then consumed by another service. You could see that all here as well. And so yeah, this tutorial has some custom eval information as well. So briefly, yeah, I mentioned the evals from OpenAI. You can launch your evaluation jobs. We took a gander at the Mango page. And basically all of this kind of means that how we do NLP and information retrieval and all kinds of text-based model building processes has like fundamentally changed. OpenAI's eval library kind of crowdsources model building and evaluation. This model recycling project from IBM also does the same thing. They surveyed the models that were open on Hugging Faces Hub. And then here you can see they were taking models that had already been fine-tuned on other data sets and fusing them together and getting better performance than a baseline single model. So if you've worked with Kaggle contests, the blend of blends models that always win or used to always win, this might be reminiscent of that, taking multiple high-performing things and squishing them together. But yeah, so that's, I think, it for me. It's a really exciting time for folks who have been doing NLP for a short time, or even a decade or more, or several decades. yeah, it's a really exciting time, and I hope that you can leverage some of our tooling and some of Arize's tooling to help you build and iterate faster, creating awesome NLP models. And here's a set of links too, as well. You can just scan the QR code if you'd rather. So we have a few minutes for questions. If folks would like to chat, sure. Walk through agents executor. Let me share my screen. Okay, so executor and then handle issues related to model reproducibility. Let me hit the model reproducibility shortly, and then I will cover the executor. So let's see here. Trying to think where is a... So relating to complex data sets, we have this tool called artifacts, and you can literally stick any arbitrary file type in it. You could stick your model weights, you could stick your data set. And so this allows you to version your data set. So like think of it like Git on steroids. It's data set versioning for your data set, but it also won't keep uploading. Like if you have these identical data sets, it'll only take a delta and be like, oh, hey, okay, your data set changed, uploading that new one. And I don't think I have an example as beautiful as this, as expansive as this, but this would show you kind of if you had a very large model or data set pre-processing and then model training and eval ecosystem, what it could look like. This would be your data branching chain. And so we have I would recommend, yeah, just checking out the artifacts page, or you can try a nice little Colab notebook here that will show you how to do artifact versioning inside of Weights and Biases. And so this should help out with your model, but also with your training data, or any chunk of data that you want. It doesn't have to just be training data. So hopefully that answers some questions. And then this is the other question was about the agent executor. And so you can see here, I encourage you all to like play around with this because there's so much going on in here. And like I said, it's only a week old, so it's a bit new to me even as well. But basically we have this agent executor that wraps the entire duration of the job. So in this case, I used a Colab notebook. I wrote a bunch of English language statements that were math questions. LangChain then wrapped those in the math evaluation operation. So not just plain English, but rather math, because it's kind of crummy with numbers. GPT is. And so, yeah, this created some outputs of math things that we asked it to do. And so you can see here, the agent executor is running the entire duration of that call. So we pass in those queries, the model gives us a response, and then at some point, the whole job concludes. And so you can see here, the executor is kind of the head honcho up there up top, followed by a call to LangChain, which then calls over to OpenAI and says, hey, OpenAI, this was probably the authentication loop at the beginning, to say, hey, I have an API key. Can I ask you a question, model? And then this is where the calculator calls came into play. So the LLM math chain inside of LangChain. And you can use whatever other favorite flavors of chains you have in LangChain. And then this duration here with the OpenAI is the same length as that entire call and response of however many, I think 4 or 5 different questions I asked up here. And then, yeah, your job concludes. And so this is the final closing loop of what's going on in your functionality. And when you're running this stuff in the notebook, you'll be able to see some nice command line output over here, but that also gets saved, that also gets saved over here in your tables, which you can then put into a report and share with your technical or non-technical colleagues, and just easily with one click, kick all that model output over. And so, yeah, really, really simple. You can publish it to a team or an individual's project. And yeah, I encourage you to check out the other notebooks as well.